Hello, my name is Paola, and this is the first part of my evidence 1. We're going to start reading the first problem. What volume of water has the same mass as 100 millimeters cubic of gold? And what is the specific weight of gold? Okay, so we have to get the volume of water and the specific weight of gold. First, what is a specific weight? Specific weight is a weight per unit volume of a fluid. And the formula for a specific weight is the following: D equals to density times gravity. To get the volume of water, we have to get first the density of gold. We know it's 19,300 kilograms per cubic meter. And the formula to get the mass is density times volume. But what is the volume of gold? Well, it gives us the volume in millimeters square, so we have to pass it to meters square. 100 over 1,000 gives us 0.1 meters square. It's right there. And once we have the density and the volume, we multiply them and gives us 1,930 kilograms for the gold's mass. Once we have the mass, we can calculate the volume with the same formula. Volume equals to mass over density. Volume equals to 1,930 kilograms over 1,000, that is the density of the water, and it gives us a volume of 1.93 meters square. Now for the specific weight is really easy. We want the specific weight of gold. We already know the density, that is 19,300 kilograms per meter square, and the gravity, that is 9.81, gives us a total of 189,333 newtons per meter square. And that's the result. Now we're gonna read the second problem. It says, a submarine is submerged at a depth of 200 meters and then levels off. How is it achieved that inside the submarine atmospheric pressure is maintained? That is more like a theoretic question, because we cannot calculate that. I put that because it is completely sealed. That's why the atmospheric pressure is maintained. The second question is, what are the pressure and total force applied to a hatch 1 meter wide and 1.5 meter long? Okay, so first, the things that we have. We have height, that it's 200 meters. We have the hatch area, that it's 1.5 meters square, because we multiply 1 meter times 1.5 meter long. We have also the seawater's density, that it's 1,030 kilograms per cubic meter. And we're gonna use the formula: pressure is equal to density times gravity times height. We know the density, we know the gravity, and we know the height. So the pressure is this one. For the force, we're gonna use this formula. Force equals to pressure times area. We have the pressure, that is this one, and we have also the area, that was 1.5 meters square. The third problem says that a hydraulic press has a 30 millimeters radial input piston and 75 millimeters radial output piston. The question is, what input force is needed to provide an output force that is able to lift a truck of 1,300 kilograms? For this, we need to use the Pascal principle. That is, force 1 over area 1 equals to force 2 over area 2. We have both radius, so we can get the area with the formula P times radius square. My first area was 0.002827 meters square, and my area 2 was 0.0176 meters square. So we clear to get the force 1. But what is my force 1? Like, do I have forces? Well, you don't, but you have to get it with the mass. You have a 1,300 kilograms and you have to multiply it by 9.81 to get the force. It gives us 12,753 newtons. So we put force 1 over area 1 times area 2 to clear for force 1, and it gives us this number as the force 1. In the fourth problem, we have to do the exact same thing as we did in the third problem, but here we also need the pressure. It says the inlet tube supplies air pressure to operate a hydraulic jack that has a 30 millimeters radius. The output piston has a 64 millimeters radius. What is the pressure should be used to lift with the crane a 2,300 kilograms mass? We have the radius, so we can get the area with the formula P times radius squared. My first radio gave me an area of 0.002827 meters square, and my second radius, that was the output piston, gave me an area of 0.012867 meters square. The mass we already know how to get the force, that it's 2,300 kilograms times 9.81. That gives us 22,563 newtons. So we have to clear for force 1. We put that force, over the area of the output piston times the area of the tube of 0.03 meters of radius. And that gives us a force of 4,957.30 newtons. But now we have to get also the pressure. The pressure, we can get it with this formula, that is pressure equals to force 1 over area 1. So we put force 1, that is this, over the area 1, that is 0.002827 meters square. And that gives us this pressure. Now I'm gonna read the fifth problem. It says, a balloon operates at an altitude where the air density is 0.9 kilograms per meter square. At that altitude, the balloon has a volume of 20 meters square. The balloon is filled with helium. It gives us the density of helium. If the weight of balloon bags is 94 newtons, what load can the globe withstand at this altitude? The first thing I did was to put the things that we have on this side of the sheet of paper. We have the density of the air, that is 0.9 kilograms per cubic meter. We have the volume, that is 20 meters square. The helium's density, that is 0.178 kilograms per cubic meter. And the weight, that is 94 newtons. So with the weight, we can get the mass, that it's dividing it by 9.81. Gives us a mass of 9.5820 kilograms, and we're going to use it for later. The sixth problem says, a balloon filled with helium has 21 meter radius and the mass of the entire globe is 50 kilograms. What extra mass can the balloon load? The first thing that we have to get is the area of the balloon with the formula of 4 over 3 p times radius square. That gives us a volume of 3879 2.3886 meter square. The next thing is to get the buoyant force. The buoyant force is calculated with the formula buoyant force is equal to density times gravity times volume. We use the density of the air, that is 1.22 kilograms per meters cubic, times the gravity, that is 9.81, times the volume that we get, that is that one, and all of that over the gravity. and that gives us this number. The seventh problem says, through a tank terminal with radius 20 millimeters, water flows with a velocity of 3 meters per second. What is the flow in liters per minute if 1 liter equals to 0.001 meters squared? And with this flow, how much does it take to fill a container of 20 liters? Well, the problem already gives us the radius, that it's 0.020 meters, the velocity, that is 3 meters per second, and the volume, that is 20 liters. First, I get the flow rate, that it's with the formula velocity times area. The velocity is 3 meters per second and the area is 0.0012566 meters squared. I got it from the radius. And it gave me flow rate equals to 0.003769991 meter squared per second. But it says that we want that in liters per minute. So I changed everything to put it in liters per minute. Once that we have the flow rate, we can get the time. That is the next question. With this flow, how much does it take to fill a container? We use the formula flow rate equals to volume over time. We clear for time, that is volume over flow rate. Flow rate equals to 226.1946. We use it in liters per minute. And on the upper part we have the volume, that it's 20 liters. It gives us a time of 0.088419 minutes. And that's it. The eighth problem says, in a large tank filled with water, what is the rate at which water from a crack that is 5 meters below the surface of the water spills? The area of the crack is 20 millimeters square. What is the water flow of the crack? The problem gives us the area, that it's 0.02 meters square, the height, that it's 5 meters, and we have to get the velocity first to get the flow rate. We use the formula velocity equals to square root of 2 times gravity times height. We have the gravity, that it's 9.81. We have the height, that is 5 meters. We multiply it by 2 and we get the square root of that. It gives us a velocity of 9.90454 meters squared. Now we can get the flow rate with the formula flow rate equals to velocity times area. We use the velocity times the area, that it's 0.02 meters squared, and that gives us 0.198,01088 meter cubic per second. The last problem says, in the wall of a large water tank, there is a hole radius of 50 millimeters, located 4 meters below the water level. How fast does water flows out through the hole? What volume of water leaks through the hole in 5 minutes? The first thing that we have to get is the velocity, and we get it with the same formula that we used in the last exercise, and its velocity equals to square root of 2 times gravity times height. Height is 4 meters, gravity is 9.81, and it gives us a velocity of 8.8588 meters squared. Then we have to get the volume, and we use the formula volume over time equals to velocity times area. Volume equals to velocity times area times time. We use the velocity that we get, the area of the hole that has a radius of 50 millimeters, that it's 0.0078539 meters squared, times the time, that it's 5 minutes, and that gives us a volume of 20.8728 meters squared. And that was it.